Duh. Here we go. Ready? Everybody say okay. Okay. Recording. Okay, we are talking about the deep sea, everybody. Let's do it. I love the deep sea. Most marine biologists will not start by, or at least marine biology teachers will not start by talking about the deep sea because it is so bananas. But I don't care. I love it. I'm doing it. I don't care. All right. So if you're going to be a successful organism, that means you. Here are things you need. You need a gas to live on, so oxygen. Or if you're a plant, you need carbon dioxide and oxygen. You need sunlight if you're a plant. If you're going to create an entire ecosystem based on you, you need sunlight if you're a plant. You need a safe environment to live in. You need nutrients. You need food. You need your environment not to crush you with every fiber of its being. And so the deep sea has a lot of dissolved oxygen because the colder your water is, the more gas can be dissolved into it. And the deep sea is where the coldest water is. It's the densest water, so it sinks to the bottom. There's no sunlight to heat it up. There's very little energy from the earth heating it up. There are hydrothermal vents, but they're very rare. And so it's the coldest place ever. I mean, some people think right now Texas is the coldest place. I've gotten so many texts from people living in Texas who are like, oh my God, it's freezing here. It's snowing. I'm like, well, then move to a better state. But they don't like it when I say that. It's fine. We don't want them all to move here. That would be the worst. You also, what else? Oh, there's lots of nutrients because they sink to the bottom. But we're going to talk about how that makes the world go round. Think about when you're like, well, we'll get to there. Okay. But the deep sea is very hard to live in because there is very little food, especially if you don't just like eating something we'll talk about called marine snow. There's zero sunlight, so there are no plants in the deep sea. How can you have an ecosystem with no plants? We'll talk about it. It's very, very cold. It's again one of the coldest places on the planet, and you are constantly being crushed by millions of tons of water above you. Just the idea of that gives me a panic attack, or like just makes me feel like I'm being suffocated. Y'all. So why would anything live here? Oh, life takes advantage wherever it can. Every place on the planet has some sort of life living on it. If you might say, but what about like Antarctica? Well, humans can live there and so can bacteria and sometimes some penguins and stuff. So life finds a way. So we're going to talk about how the deep sea works. So one of the things is, okay, we don't have any plants. So how do we support the entire ecosystem? So plants give us, I'm looking outside, there's a squirrel eating my bird seed. Well, you know what? That bird seed comes from a plant. The birds are really mad about it. The squirrel's doing his thing. It's fine. I'm not going to yell at him right now. So what about the deep sea where there's no plants? We have what's called marine snow. Oh, it's so pretty. It's snow. Oh, no, it's not pretty. Don't eat that. That is mostly puke and not puke, but mucus and poop. And it is essential to the planet. If we don't have it, everything will die. And it actually could be a way that we decrease global warming because we might be able to sink carbon into the deep ocean through marine snow. So imagine it's the weekend. You're on day 3 of your break. You haven't gotten up before noon in days, and you're sitting in bed eating Doritos, watching Netflix, and crumbs are getting everywhere. And you're like, whatever, it's gonna go on the carpet. I'll vacuum it later. Well, there's no vacuuming in the deep sea. So what happens instead is everything, like a shark is eating something up here, and then it rips it apart because it doesn't have hands to gracefully put it into its mouth. And so then like pieces of whatever it's eating sink to the bottom. Okay. And also fish are always covered in mucus to protect them from microorganisms that are trying to devour them. And so that mucus will also occasionally be lost and then drift into the deep sea. And so this is just, and poop, so much poop, y'all, so much poop. There's just all of that comes together and it's this weird white, floaty, pretty, I guess, looking stuff called marine snow. I hate it. So I have friends who study it and they are just like, oh my God, look at this marine snow I found today. And I'm like, no, why? Why are you showing me this? This is gross. But they categorize it by size. Like this is a very big piece of marine snow. Again, poop and mucus, probably some puke, I don't know. And it actually, again, there are people who their whole life is categorizing marine snow. Cool. Good for them. Not doing it. It's important, but I don't want to deal with it. But the good part of this is all of this is actually very nutrient rich because it's chunks of stuff that, was living, or it's poop. And that feeds the entire deep ecosystem, starting with the microorganisms. Okay, so This is supposed to be deep sea microorganisms, but I see that these might be algae, and so that is false. Okay, fine. But these are definitely deep sea organisms. They're very, very small plankton that we'll talk about later. But we also, those are the microorganisms. You also get these things that look like flowers, but are actually animals that are feeding on, they filter the water, okay, so that they can, get all of that delicious marine snow. So tasty, so squishy. And then you have, of course, the crazy jellyfish of the ocean. We'll talk. I'm going to do a whole thing just on jellyfish. I bought a jellyfish mask for it. It's going to be fantastic. It lights up, y'all. And then there's these things called salps or tunicates, and they are bananas. Let's look at them. Deep sea salps. They are very, very efficient microorganisms. They look like plastic, but they're actually like this is huge. Like each one of these is like the size of my hand, and then they form these, like each one of these, like bloop, here's like the head of it and then the rest of it, and they stick to each other. So they make these giant, so here's how big each one of it is. And then they make these really, really long colonies. And they just like, here's another one. What is that? Is that plastic? No, it's a salp. What is happening? What even is this? We never talk about this in class. It's because we don't understand it. They are ancestors to vertebrates, which is us, but we don't want to admit that that thing became us. That's a globby nothing. That's so boring. What is it? But also some of them can kill you, so that's fun. Thanks, ocean, for being terrifying always. Yay. Okay, so that's what this guy is. And then there's the vampire squid. So if you play Animal Crossing, you may have collected a vampire squid. Anybody collect a vampire squid? Yeah, all right. So technically we can't collect them unless you're like on a boat in the deep ocean, because they live very, very deep and they look so scary. Their scientific name translates to the vampire squid from hell, because marine biologists are very dramatic. But actually so is the vampire squid, because what the vampire squid does is he looks so scared. So it's probably like about this big, I think. It's off screen. And if something comes up and it's going to eat it, it's like, oh, fuck you, buddy. And it flips completely inside out. So it shows its spikiness. And it's like, oh, eat this. Except that these are all squishy. But you don't know that if you're a deep sea organism. You're like, oh, there's a ball of spikes. No, thank you. And you go away and you don't actually eat this thing. And so you're like, oh, something so big and scary must eat a big scary fish, right? No, they have this secret tentacle that's really small compared to the other tentacles that is called its feeding tentacle. And this is why it's not technically a squid, because no squid do this. We don't know what it is. It's not a vampire or a squid. And so it has this long sticky tentacle, which just like is out there. It's basically like a really long like snake tongue. Or what else? What eats a sticky thing? Like a frog's tongue, just like out there, swap in the ocean, and then it like pulls it into its mouth and slurps all the marine snow off. So it's like if you ever ate Lick-O-Mates, you guys have that with like the stick, you put it in the powder and then you lick it. No, is that a weird 80s thing? Okay, maybe some people did. Okay, so so yeah, right. It exists, right? And so it's so fun. You just like, you lick the thing, you put it, yeah, that's what this guy does, but it's attached to him. Y'all, bananas. Fun dip. That's what's called fun dip. Thank you. Yes, fun dip, Lick-O-Maid. Yeah, depending on your region, fun dip, y'all. So the vampire squid looks terrifying, but it's basically just playing fun dip with the ocean. Good. So what if you don't want to eat? We can talk about filter feeders forever, and we'll talk about some of them. Some of them have actually like their littoral or beach counterparts are very they are filter feeders. So like the sponges, I like how the first thing comes up is SpongeBob. Not that kind of sponge. Rude. No, this kind of sponge, these are straight up filter feeders. They take in the water, they spit out whatever they don't need. Very exciting. But if you are a deep sea sponge, you tend to be more carnivorous. So what is that about? For a spew. And so they have, look, this looks like someone designed it, but it's evolution. Evolution was like, you know what's best? This shape. And so you get these weird 5 little, like, so the sponge starts here, and then it has these 5 arms that come out, and each one of these, as soon as something passes by and gets stuck to the end of it, it collapses. Whoa. And so it's also called, sometimes it's called the Venus flytrap sponge. There's also a Venus flytrap anemone, which y'all, I'm gonna warn you right now, looks terrifying. Ready? Oh, actually, this is actually very adorable. But the first picture I saw of it looked like this, but they look like this, and they act just like a Venus flytrap. It's just convergent evolution. They just wait for something to swim by, and then chomp, they eat it. Thank you, goodbye. Okay, look at this little, it looks like someone designed it. It looks like it's from a Mario game. But the deep sea, y'all. It's just, oh, here's the first picture I saw. What is this? This is gross. What's happening? That's what it looks like. So exciting. This is my favorite though. Okay. So can you please focus? Absolutely not. Okay, so what if you don't want to eat marine snow? There's two things you could do. You want to eat fish. You're like, I love eating fish. That's why I live in the ocean. I don't have Grubhub to order from Sugarfish or whatever. I am going to instead, I'm going to have a really slow metabolism because it's actually really rare to find food in the deep sea because it's the biggest environment and also it's the hardest to live in. So there's actually not very many organisms that live down there. They're very rare. It's about 25% of what you see at the surface. So that's it. Okay. So you could either be something that has a very, very slow metabolism, like what the shark biologists call the like dumb puppy dog of the marine world, the not Greenland, it's related to the Greenland, but the six-gill shark. Look at this. This does not inspire fear. These guys are like 8 feet long, and I still would be like, what a dumb shark. What are you going to do? Gnaw on me? What's happening? Because look at its face. It doesn't inspire fear. This isn't Jaws. What's happening? But they have a really slow metabolism. When there is food, they'll eat it, but they don't really search for it. They're just like swimming around, waiting for food, hoping for the best, not really doing anything. Okay. That's why sharks that are like this one, and the Greenland shark can live up to 500 years. Why? Well, this metabolism is so slow that by our standards, it seems insane. But by them, they're just like, I might eat this year. It's cool. What? I'm hungry right now thinking about not eating. Oh, it's a problem. Okay, so good job, weirdo shark. You could do something else, which is that you have an unhingeable jaw and your stomach will inflate like crazy. And that's what the gulper eel does. So look at this. Look at this sexy beast right here. So here's its eyeballs, okay? So there's its eyeball, there's its nose, and then its mouth, which normally would stop right here, goes all the way back. Okay. And its stomach can completely inflate. And so very recently, the MBARI, the Monterey Bay Aquatic Research Institute, they're the ones who do a lot of the deep sea underwater, just like live streams where they're discovering new animals and making fun of them at the same time. It's fantastic. They encountered a gulper eel. Oh, that's hard to say with the Texas accent. And it was doing this weird display where it was getting ready to eat something. So it puffed up its cheeks. And again, here's its little tiny eyeballs. Okay. There's its face right here. And then it's like if you took your face and then like, it's creepy when the Joker has the scars that go up its cheek. This is like that, but like times 1,000, and it actually opens. Terrifying. So they found it and it was just doing this because it was like, you know what? I'm going to eat that camera. Did not eat the camera, but it was really excited to eat the camera. We actually haven't found any of these organisms that have food in their belly, which is weird. So where's that food? At least not the gulper eel. We know how they eat, but we still haven't collected any specimens where they have food in their belly, which usually when you catch an animal, if you catch a fish, there's food in its belly because it needs to eat. So we don't know why we haven't found any with no food in its belly, but we have found anglerfish with food in its belly. Look how sexy this beast is, y'all. Oh, your faces are correct. Ugh, it's not cute. So this is an anglerfish. You can actually see whatever it ate has bioluminescence that's glowing through it. Oh no. And so it took in whatever it is, and their stomachs are so extendable. It's so rare to find food in the deep sea that if you find it, you better eat it. So it's like if I go hiking and I see a coyote, I better just swallow it, hope for the best. Delicious. Don't eat me from there. Okay. And so we're going to go off of this, jumping off the anglerfish, and we're going to talk a little bit about how does this pretty lady make baby anglerfish? Because when you look at this fish, don't you just think, yeah, I want to mate with that fish. It is clearly a species that needs to continue. Well, you do if you're an anglerfish. And you may or may not know this. If you watch True Facts, you know all about this. The anglerfish, look at, some of them are a little more cute than others. Oh, this one's so cute. If you watch Blue Planet, this is a picture from Blue Planet. Some of them, not so much. Oh, that's cute. Oh, but they do something called sexual parasitism. And so I didn't get a chance to find this picture because every time I'm doing research for this class or this seminar, I get very distracted and I'm like, what's that? And then I realize it's time to start the Zoom. And so let's talk about sexual parasitism, but I don't suggest Googling that. I would instead Google anglerfish mating. Now, all right, cool. What happens with this? So again, it's very rare to find a mate in the deep sea because the chance of you encountering another of your species and not eating it, which is a huge issue in the ocean, is very, very small. So you might come up and be like, "Hey, let's make babies," and then the other fish is like, "I'd rather survive. I'm gonna eat you. Bye," and then it eats you. That's a problem. So what the anglerfish does is the male is actually very, very small. It's called sexual dimorphism, where one of the sexes looks very, very different from other ones. We see this all across the animal kingdom, even in the plant kingdom. So sexual dimorphism. Let's see some good. Oh yeah, like when birds have different colors, that's sexual dimorphism. In the birds, it's because the males have to do more work to get the attention of the females because it's so hard. The idea being that in evolution, it's so hard to keep and make eggs that the males better work hard to make sure that they are worthy of that genetic, okay, those genetics. Some frogs are doing what's called plexus, which is basically frog foreplay. But again, you can see, okay, the peacocks have sexual dimorphism. The females, the peahens, are much smaller and less colorful. Lions, the testosterone in lion males will cause them to have their big manes, and humans do it too. We see that as you hit puberty, if you are releasing testosterone, that causes your muscles to get bigger, that causes your larynx, which is a muscle, your voice box, to also get bigger. And it's like putting bass strings on a ukulele. All of a sudden, it's going to be a lot deeper and not work. In that analogy was a bad one, but it's why bass strings are so much deeper than regular guitar strings because they're so much bigger. So the same thing's happening in your voice box. But it takes time for you to get used to those bigger voice strings, basically the vocal cords. And so that's why voices will crack because your body is still learning how to use them. Okay, spiders also do it, but again, the females tend to be bigger, which is like what the anglerfish do. So here's our anglerfish, pretty lady. The males are so small so that when they avoid being eaten by the lady anglerfish, what happens is they climb on. It's like the worst hickey in the world. The males will, like, anywhere on the body, they swoop, they suck onto it, right? And they eat into the side of the female, right? Gross, horrible. And then they dissolve everything in the inside of themselves except for their testes. So they basically just become little bags of sperm that are permanently attached to the female. That's it. So you can't ever lose your mate now because you're literally attached to them forever. So some of you may have had girlfriends or boyfriends like this. In humans, that's a toxic relationship. In the anglerfish, that's the only way they can mate, because otherwise the chance of you meeting another animal of your own species is so small. I know, Elizabeth, I know. And so, yeah, gross. It's the worst, but it's also amazing. I love it so much. Also, if it is a surprise to you that this is a toxic human relationship, we can talk. Someone just asked, which classes do I teach? Well, this weird thing, but also earth science and astronomy. Y'all, you should all take them. They're so good. And bananas. Molly says, yes, correct. What are we talking about right now? Dinosaurs. Oh, fabulous. Okay. I'm going to go into this more next time, but I'm going to get rid of the frogs having sex. Okay. One of the big things that is a big problem in the ocean, in the deep sea, is light. There's no light. So if there's no light in a terrestrial environment, if you have a cave system, like cave moles, are there cave moles? Am I totally wrong? Let's find out. Nope, they're not real. Okay. Cave animals and blind, they just lose their eyes. They're like, you know what? I don't even need eyes anymore. So this especially happens in cave fish and cave lobsters. I don't know about any other. Those are just the ones I know about. They lose their eyes completely because they don't need them. There's no light in a cave. I don't need them. But if you look at the deep sea, they still have eyes. So what are they looking at? And the answer is my most favorite thing in the world, bioluminescence, which I'm going to do a bigger talk on later, but we'll just talk about deep sea bioluminescence right now because some of it is so bananas. All right. So bioluminescence is the creation of light from an organism. Okay. Think about that. Oh my gosh. Do you know how bad it would be if you are in high? Whoa, did I freeze? Oh no. What if, okay, so imagine all the things that our bodies do right now that you're embarrassed about. And then imagine like you see your crush and then suddenly a blue light goes off on the back of your head. That would be the worst unless you could control it, right? But oh my God. So some of these animals, they'll do something where it's called light bombing. So if they're trying to avoid getting eaten, they literally squirt glowing fluid, basically glowing mucus at their enemies, and then their enemy gets covered in light, and then some other animal will see that and then be like, I'm gonna eat that, thank you. And so it's a protection effect. There is, let's see what else. Oh yeah, I just the one that everyone always thinks about is the anglerfish. So the anglerfish from, again, like the one with the, now you'll never think of the anglerfish without thinking about the parasitic males, though, will you? But the anglerfish, of course, we know the anglerfish mostly because their little glowy light here is in Finding Nemo. They see the glowy light and then, oh no, scary fish is going to eat me. That's exactly what those glowing lights are for. There are fish that, there's something called the tail light shark, because again, scientists are bananas. So the tail light shark releases basically from its butt, from its cloaca. It's also from these guys. Excellent. The cookie cutter, my favorite. It releases a cloud. Y'all, this is like your worst day when you like think you're farting, but you're not actually farting, except it glows. Okay, that's what's happening here. So it releases a glowing fluid it's fluid and mucus out of its one hole, and then swims away in the opposite direction so you can't see it. Amazing, except terrifying. Oh my, I'll often think about, what if we did this as humans? It would be the worst. Oh, what else do I want to say? Oh, cookie cutter shark. Look, again, this is a shark, but you don't look at this shark and think, oh, I'm so scared of this. Oh, it's so scary. No, you look at this shark and you're like, who did that? Who drew that? That's a bad drawing. But this is a cookie cutter shark. And the cookie cutter shark, I wonder if you can do an Animal Crossing. I don't know. Their faces look like this. They have one really big jaw and then like nothing down here. And the reason why they're called cookie cutter sharks is because when they take a bite of an animal, it leaves a cookie cutter mark. Like they glom on, they suction onto it like a male anglerfish getting it on, and then they spin around really fast, and that bottom giant, basically singular crazy tooth cuts a circular hole. Now, people used to find animals washed up on the beaches with these cookie cutter bites and think, oh my God, someone's shooting dolphins. What is happening? But what happens is these fish, they sneak up onto these other animals. They take a bite and they leave it alive. So if you find an animal with cookie cutter bites, it's dead for a different reason, or it got an infection from its cookie cutter bite. There are pictures of humans that have been bitten by cookie cutters. Absolutely not looking at that, but Google at your own peril. But the fun thing about cookie cutter sharks is that they are very sneaky with their bioluminescence. Because if you're an animal in the water, we always think about this when you think about if sharks are looking at you like a tasty treat. You're in the water at the top of the water, and then an animal's looking up at you like, I think I'm going to eat that because I can see their shadow. So when cookie cutter sharks light up, I don't think I said something else. When they light up, they only light up most of the bottom of themselves. You actually see a lot of animals light up their bellies so that if you look up at them, you can't see their shadow. They don't have a shadow anymore, but they leave one little patch. So if you're another animal and you see a bunch of cookie cutter sharks swimming together from beneath, you're like, there's a bunch of little fish. I'm going to go eat them. They won't even know I'm coming. And then surprise, cookie cutter attack. And then you get a bunch of bites taken out of you instead. Because y'all, the ocean is amazing and terrifying. And I love it so much. We're going to talk more next time. I'm going to stop talking. Does anyone have any other questions? If not, I'll see you next week. Should we talk about bioluminescence or jellyfish? Jellies? I know, they're both so good. Jellyfish? Done.
Yeah.
Bye, everybody. I love you. Mwah, mwah, mwah.
Bye. Thank you.